I'm going to explain this. As you know, the first example takes like forever. It seems like it's forever, but it's the next one would be 3 minutes or under. So we're going to cross out every time we. So let's start with a very simple example. So let's say 2x minus 4 divided by x plus 1. What type of function is it? Of course, it's a rational function. Yes, it's a rational function. So I'm crossing out or checking everything when we look at each and every item. What about the domain? These are not friendly functions. So you have to be very careful.
So it's not going to be the negative. It's not going to be negative today and positive.
Well, so what is the domain then? So remember we solved rational equations. What was the condition if this were part of a rational equation? What was the condition we wrote? That's it. That's the only condition. That's the only potential risk, that the denominator is 0. Only when x is -1. Everything else you will be able, if you plug it in, you'll be able to get a number. Very good. How do I determine the x-intercept? Very good. So I have f of x equals 0, or 2x minus 4 over x plus 1 equals 0. By the way, this is not the order in which you should go by. It doesn't matter. The order is not important. As long as this is the first, the rest you choose. Oh, there is a somewhat of an order, though. So when is a fraction 0? Only when cross multiply, right? We've done this. I know it was a month and a half ago. Cross multiply, you get 2x minus 4 equals 0, or x equals 2. Is this okay? Yes, we cross multiply and we get 2x minus 4 equals 0, and we get x equals 2. Everyone okay with that? Very good. So this is done. The y-intercept, please. The y-intercept. How do we determine the y-intercept? We replace x by 0. Very good. So then f of 0 is? Yes. -4 over 1. Very good. -4. Good. So that is done. We identify where the function is undefined. So that was done. And now we have to differentiate between these two. I'll give an example of that, and I'll give an example of this. X plus 1. So if I factor out 2 at the top, x plus 1 does not simplify with the factor of x plus 1 from the top. There is no factor of x plus 1 at the top. Agreed? So x plus 1 stays in the graph, in the function. It does not go away. So I will immediately say, right under this bar, or these bars, that x equals -1 must be a vertical asymptote. Okay. So now is the time to talk about this. What does a vertical asymptote mean? It's a vertical line, which is x equals -1 in this case, that the function cannot cross. But it will come close to, as close as possible, either going to the positive infinity or going to negative infinity.
But I'll never touch it.
On the other side as well. Not both, because it will not be a function, right? So it's either this or this, either this or this. This is a vertical asymptote. It will not cross it. There is no value there. How do I know where it's going? I don't. First, I will write infinities, because once I know that this is a vertical asymptote, the sides must be infinity. But I don't know if it's positive or negative. No problem. I will pick two numbers close to -1, like -1.1. Notice that I do not put them in the table. I'm not going to plot those numbers. I'm just using them. With -1.1, I hope you agree that the denominator is negative. Just a sign. Would you agree? With -1.1, the numerator is negative as well. So what will be the sign of this infinity? Awesome. Great job. With negative 0.9, however, the denominator will be positive. The numerator will still be negative. So which sign will this have? Right. I don't care for these anymore. I only use them to find the sign of those infinities. So when will the function have a hole in the graph? I'll show you an example in a minute. When it will have a hole in the graph if this denominator, one factor from the denominator, goes away with an x plus 1. At x plus 1, in other words, at negative 1, the function will still be undefined. But if the factor goes away with a similar factor at the top, that's going to be a hole in the graph. We're going to get an example in a minute. Behavior of the function left and right of the V8. Done. We determined on the left-hand side positive infinity, on the right-hand side negative infinity. Max min, I have to use a calculator. So that's done. Symmetry, not possible. If a function has a vertical asymptote at negative 1 and it doesn't have a positive 1, cannot be symmetric. So I'm going to write not symmetric. I will write that f of negative x does not equal f of x, and it does not equal negative f of x. So that's done. So symmetry is done. Range, I have to see the function. This is my last item on the list that I have to talk about. Okay. These functions, same degree of the same degree, eventually, at infinities, will approach a number. Which means that this is a horizontal asymptote, and the function will either come from above and get closer and closer to it at infinity, very far away, not here in the middle, around the origin. No, no, no. All the way out there. It's the end behavior. Now we don't have this. We don't have this. We don't have this. We don't have this. These are polynomials. Type 1 rational function will approach a number. How do I know which number? It's for type 1, always the leading coefficient over the leading coefficient. What is the leading coefficient of the top? 2. What is the leading coefficient of the bottom? Yes. So end behavior for type 1, for type 2 is even easier, is y equals 2 over 1, which is 2. So this will be 2, y equals 2 horizontal asymptote, 2, y equals 2 horizontal asymptote. The chart is filled up. We're done. Okay, so let's attempt the graph. I don't care for any information other than the table. Everything else is redundant. When we graph a function with asymptotes, we must graph the asymptotes first. This function has 2 asymptotes. One is vertical at negative 1, and the other one is horizontal at positive 2. That's the starting point. They're not solid lines because they are not part of the graph. Then I plot the points I have. I have 0, negative 4, 1, 2, 3, 4, and I have 2, 0. And now I analyze the table. So let's analyze the table together. From approaching 2, it's coming closer and closer to negative 1, approaching infinity. From approaching 2, closer and closer to negative 1, going to positive infinity. On the other side, it's coming from negative infinity. It's crossing the y-axis. It's crossing the x-axis, approaching 2. One more time. From 2, approaching infinity. From negative infinity, crossing the y-axis, the x-axis, and approaching 2. So 2 to infinity. Negative infinity. Crossing, crossing. That's the graph. It should be smoother. And this is the vertical asymptote. It does not touch the vertical asymptotes. So this is f of x equals 2x minus 4 over x plus 1. Now with the graphing calculator, please be very careful how you put it in. Make sure you put parentheses around the numerator, which is 2x minus 4. Make sure you put parentheses divide by, parentheses around the denominator, which is x plus 1. And the calculator is not as smart as you are. It does not know to draw a horizontal asymptote if you don't ask it to do it. So let's use the standard for a moment. Here it comes from 2 to infinity. From -2 crossing at 0, -4 crossing at 2, 0 approaching 2. And here comes the horizontal asymptote. However, I'm really sorry I don't know how to graph, how to insert the vertical asymptote here. There is something that I have to change in the software. I don't know how to do it. I would have to investigate how to do that. In my old calculator, where is my old calculator? The vertical asymptote pops up automatically, I think. In the newer calculators, you may have to insert it. I'm not sure. So parentheses 2x minus 4. I haven't checked. So okay, and 2. Oops, I didn't mean that. And 2. Let's see what happens when I use standard. No, it doesn't show the vertical asymptote. Who has an older? Yes. You have to put
Let's
it in.
say yours has it.
But you have to put it in. You didn't put it in. Yeah, you have to put this.
See, I have the one, the newer one.
Yeah, graph it for sure.
Think yours has it.
Yes, the older calculators, you do not have.
The ones has it, the newer
Yeah.
ones don't.
The older calculators, they show the vertical asymptote, but the newer ones do not.
That amazes me.
But there is a way of inserting it. I just didn't research the software. My apologies.
I'm sure you can find it. You can find it.
Oh yeah, yeah. So this is a rational function of type 1, and type 2 is even easier. Any questions? I would like us to look at one function with a hole in the graph. Like for example, f of x equals x minus 2 and x in front and over x squared minus 4x minus 6x plus 8. Of course, I'm going to ask you what type is it, and you will say,
Rational.
yes, but which type? Because we have 3 types. Is it type 1, is it type 2, or is it type 3? Yes, it is type 1 because the degree at the top is 2 and the degree at the denominator is 2. So it is type 1. I will continue by factoring the denominator. How do I factor a denominator? Very good, x minus 2 and x minus 4. I have to state 2 restrictions. If you remember, we said that from a month and a half ago. We must state the restrictions before we simplify the function. Very good. 2 and 4. However, and this is still carved in stone, but now I can simplify. So this will be a hole. This will be a vertical asymptote because the simplified form is this. And the factor of x minus 4 does not go away. That stays as a vertical asymptote. Ready? Domain, please. And you can say, can't you see it? It's right there. Your nose. And I'll have to say yes, you're right. What do we know once we know that x equals 4 is a VA? What do I know left and right? Infinities. Very good. Let's use 3.9 and 4.1. With 3.9, positive over, good. With 4.1, positive over, good, done. The horizontal asymptote and end behavior. Type 1, leading coefficient over the leading coefficient. But of course you have to make sure that they are in descending order, because otherwise you may not be able to identify correctly. So what is the leading coefficient at the top? 1. What is the leading coefficient? Good. So 1 and 1, y equals 1, horizontal asymptote. Please plug in 0 and tell me what you get. It's 0 over negative 4. How much?
Yeah.
Perfect. Now I need left and right here, but they will not be infinities. We plug in 2. Please plug in 2 over negative 2. 2 minus 4, negative 2. So 2 over negative 2. That's it. Negative 1, negative 1. No symmetry. You cannot have a hole in the graph and then. Yes. Which one?
The hole under the 2 why aren't they?
They're not infinities.
Yes.
It's a hole in the graph. That's just a hole in the graph, yes. The graph does this. Is it clear how we got the negative ones? Yes. Okay, so now let's analyze the graph. We're approaching 1, down to the origin, going through this point. I'm just looking to make sure that I put everything in the correct order. 0, 2, and 4. Correct. Origin. Going through this point to comma negative 1, and then to negative infinity. On the other side, from positive infinity to 1. One more time. From 1, going through the origin, going through an open point, hole, to negative infinity. On the other side, from positive infinity to 1. Let's graph what we have. When we graph a function with asymptotes, what do we have to graph first? Now you see, we didn't even write anything. We just filled in everything in the table and we're done. We didn't write anything on the side now. So first we have to graph vertical asymptote at 4. A horizontal asymptote at 1. I have to plot 2 comma negative 1 like this. This is 2 comma negative 1. I have to plot 0, 0. Of course, that's why I was just looking. Oh, what did I do now? Okay, very clear. Thank you very much. This was, I said, how can you go through the origin and then something is not? Thank you very much. Good. Yeah, I have the tendency to move them around. Okay, so from 1, crossing at the origin, going through this point, approaching negative infinity. From 1, going through the origin, going through this point, approaching negative infinity. On the other side, from positive infinity to 1. So this is our function. What was it? X minus 2 over x squared minus 6x plus 8. We have 7 minutes left, and I'd like to, if you would like to, either work on another problem or look at type 2, which is even easier than this. The only difference The only difference with type 2 is that the horizontal asymptote is always 0. Yes, yes, of course. So let's take a look with another one with a hole. So let's say f of x equals x divided by x squared minus 4x. And this is type 2. So we are going to shoot 2 rabbits with 1 bullet. We are looking at type 2, and we are looking at another one with a hole. Ready? Of course, I will have to factor out x. I'm not allowed to simplify before I state 2 restrictions, and they are 0 and 4. Now I'm allowed to simplify, and I get this. Let's start a table. What is the domain of this function? The original function, of course.
So look at the hole with the you can
Yes. So 0 and 4 and infinity. The factor 0, x equals 0, will be a hole because it went away. It's no longer in the final simplified form. But x minus x equals 4 will stay as a vertical asymptote because the factor is still there. The only difference from type 1 is this. Y equals 0 is the horizontal asymptote for all type 2 rational functions, where the degree in the denominator is stronger, bigger than the degree in the numerator. What would you say happens left and right of the vertical asymptote? It must be infinities. What about 0? We don't know, so let's plug it in. Negative 1/4, negative 1/4. Perfect. Now we have to establish the infinities with 3.9 and 4.1, and we're done. It took us less than a minute. So with 3.9, is it positive or negative? I only need the sign. Of course, makes sense. With 4.1, that's it. We're done. So let's graph. We start with the asymptotes, but this is an overkill. There is no need to do this to establish y equals 0 because it's the x-axis. At 4, yes, x equals 4. And let's see, where does this go? 0, negative 1/4 is a point here. So from approaching 0, going to negative infinity, and from positive infinity to 0. And this is the function x over x squared minus 4x. And this is an empty point. It's a hole in there. If I want to ask you just one thing, and I'll take attendance. So what is the range of this function? Be very careful. Very good. Union, negative 1/4, oops, comma. I'll erase that. 0. Union, 0 to infinity. That's the range of that function. What about the other one? I forgot to ask about the range on the previous one. Let's go back for a second. What will you say about the range of this? From negative infinity to negative 1, union from negative 1 to 1, and then from 1 to infinity. See how much you know about these functions now? So be very careful. The calculator is not as sensitive as you would expect it to be. It will not show you the whole. So parentheses around the numerator, and we had x, and divide by, in parentheses, x squared minus 4x, close the parenthesis, and I'm going to use the standard And look what happens. It kind of shows, kind of. So you can zoom in here and you'll see there is a hole in the graph. Or you can simply say second and table and try to plug in 0 and you'll see what happens. It's right here at the top already. Because I did not change to the ask mode. So now when you plug in 0, of course, it's an error. Any questions for me?